Alright, so let's play a game. I've asked AI to design some specific shape, and that's what it ended up with. Guess what it is? Lock in your answer. 3, 2, 1. If you said an egg, technically you're right. But does it look like an egg at least a bit to you? I wouldn't put it in my breakfast. So let's explore why this happened and how AI can be helpful with 3D design. Welcome back to Taboretum channel. I'm Tomek, and I will take you for the journey with AI 3D design today. Let's get to it, and let's start with Meshy.ai, which is a online service where you can design stuff with AI. And as you can see here, people are designing many interesting objects here. They look good, they are pretty complex, and they're all toys. And I use CAD software and 3D printing to design engineering stuff and technical things, right? Like fixtures, like spare parts, and so on and so forth. So let's give it a try, and let's ask for a model here that I asked for an egg shape, something super simple, and I ended up with this potato here, with these nice hollow things here, irregular shape, and if you wouldn't know that this is an egg, you would have no chance, right? When the texture is applied, it is a bit more eggish, but just because of the color and the texture, right? If you look at the pure shape, it's a potato or something alien stuff. It's not an egg. Now let's play another game and let's try to create a Halloween pumpkin. Funny Halloween pumpkin. And let's generate. I haven't played with any parameters here. It is generating, and let's see what we will get. And here you can see other shapes generated when I asked for an egg. This looks like a strange shaped coconut. This is maybe more like an egg. This one is also strange. And we can get to a pumpkin. Yeah, isn't it cool? So what happened here? Why the pumpkin looks cool and this one even cooler? Let's see the next two, and an egg is a problem. You know, when I would ask you to each and every this one on the bottom here is something is wrong with it, but let's say that at least 2 or 3 out of 4 are nice, right? And if we say let's go with this one, we can spend some more credits, generate a texture, and it will look cool. And why is that? Because there's no, what defines this pumpkin is the high level idea of a shape, and then some features, some colors and stuff, right? So we know there will be eyes, there will be some details, and we cannot actually pinpoint how these details will look like exactly, but we have a general idea. So it's not that complex to generate something that we will know immediately that it is a Halloween pumpkin. If you think about an egg, it is a very geometric shape, so it's very engineering stuff. It was designed by Mother Nature to fit the purpose, let birds reproduce, and it is a perfect shape, right? And if you would, even if you would ask a human to paint or draw an egg, it will be probably roundish, but not super precise. And if you think about AI models, they usually have some rough idea how things look like. If I will ask any of you to take a plain piece of paper, a pen, and draw a map of your country, well, your fellow citizens will know that this is this country, but it will not be precise because you only remember roughly the shape. So that's why AI struggled with generating directly the shape of an egg, and we'll wait for the texturing of our pumpkin here. So my thought was, well, wait a moment. LLMs are good in writing code. So let's ask AI to write a code that describes an egg. And honestly, I was using at the very beginning of my 3D printing journey, I was using OpenSCAD as the solution, and I was writing quite a lot of code. So it's a simple tool, and you can say, I want a sphere with diameter 20, and Fn is number of triangles, and I want a lot, so I will say 100. Press the play button, and I have a sphere. Maybe not strange colors, but that's it, right? And so on. I can have a cube, and then I can have operations on these shapes like a intersection, cutout, and other stuff. And in the meantime, here comes our Halloween pumpkin. It looks cool, right? It has colors. It's great, right? Because it's not that precise. It's not a mathematical representation. Probably if you would ask a botanist, maybe this is the shape that the pumpkin will never grow to. But nevertheless, we know what it is, and it's cool. We can print it, paint it, and yeah. But what if we want a precise shape, a gear for replace a spare part for something? So we have OpenSCAD, and we want to generate this code. I'm using a openrouter.ai to play with different models. Okay, let's start with the older version, ChatGPT 3.5. Let's chat with it. And our prompt will be simple. Generate OpenSCAD code representing an egg shape. That's it. We will copy it for future, and let's see what happens. And we've got immediate answer. I will copy it. Let's switch for a second to the big OpenSCAD installed version, and let's see if we'll end up with the same result. No, it actually works. So we will be using this one. According to ChatGPT 3.5, this is an egg. Nice, huh? Okay, so let's get there and let's switch to something else. Let's use Grok 2 and see if it works. Let's retry. Okay, so we have Grok figuring out how to do that. We'll use a Bezier curve, and then we use rotate extrude. Might make sense. Yeah, and a lot of text because these models like to talk. Yeah, let's try it. Let's copy. Get back to the OpenSCAD. New file. Preview. Nothing. I got blank screen. Okay, here's the modified version. Nothing. Again. Let's just generate the pure egg. Ah, yeah. Wait. Now it's better. And it is cutting it. Why? I have no clue. But the egg itself cut off the bottom of the sphere to make it egg-shaped. Okay, so this is an egg, you see? Okay, so let's switch to another model. Let's turn off Grok. Let's add another model. Let's go with OpenAI something. Oh, Gemini. Flash 2. Give me an egg. It's Gemini egg. on Google Vertex, tons of code, but let's see. Maybe this is gonna be a nice egg. Yeah, something egg-shaped. A lot of code, but to me it looks like more of a football ball, rugby ball, right? Whatever it is. Well, or a zeppelin. It's not an egg for sure, right? It's symmetric, and I don't know why so much code. I will also show you a Grok egg that I experimented before because I played with it a bit. So this is an egg, according to Grok, right? Nice, sexy, not very eggy, but maybe tasty. And I said it should be more round. So this is another egg that I got from Grok, and you've seen on the. It's super interesting to guess what the heck the thing was thinking. But I think the idea here was that an egg is a combination of a sphere and a cone. But yeah, interesting. Let's go for some other model. What else do we have here? Let's use famous DeepSeek. And I'm sure DeepSeek will spend a lot of time reasoning. Yeah? You have some equations, more equations, and usually the DeepSeek is thinking a lot and thinking and reasoning and another. And yeah, rotate extrude is one of the options. Simplifying. Yeah, and yeah, it started to generate some code. So we'll let it reason for a moment. Reasoning. And in the meantime, let's create a new room. So we have DeepSeek reasoning here, and here we would want to use Claude. Let's use Claude 3.5. Let's chat with Claude 3.5. Here's the, you see these not reasoning models are way quicker. And let's see, DeepSeek is still deep in thought, right? I don't know if we will actually get an answer, but here is the Claude 3.7 Sonnet. Okay, so Sonnet ended up with two versions. This is the first one. That's interesting. And we have also a parametric version alternative, which is probably even more sexy. Let's see. Where's the thing? Okay, this is even more sexy because it's invisible. Now we'll add Sonnet 3.7 and let's redo it. And in the meantime, let's see if DeepSeek is deep in thinking. So we'll never get anything out of it, probably. So what happened here? Okay, so let's do it again, because it's also, yeah, so Claude 3.7. Egg-shaped parameters, how to use, copy to, yeah, let's copy. And get to OpenSCAD, Claude 3.7, an egg shape. Wow. That's a nice one, right? Probably a very tasty scrambled eggs will be cone scrambled eggs. Yeah. So let's drink. It's crap. But watch this. Another model. This time Sonnet. Thinking. So reasoning. So it is figuring out how to do that. There are different versions, some code, some equations describing the egg, some other consideration, other piece of OpenSCAD. But wait, but I realized this probably might not work as expected. Some other code, more code. So it is actually trying and analyzing what it produced, getting back to the idea how the egg should look like, and spending some more time trying, right? And remember that it is an intellectual exercise for it, right? Because it can't see how it looks like. It's not executing this code. It's just analyzing different versions, and it might take a while. And I did that yesterday, and we should be pretty impressed. I'm not sure I got this right. Let's have a step back. It's honestly, it's pretty interesting to read how it is thinking. So lot of thinking, a lot of tokens. It costs money, actually, as you can imagine. It's like a stream of consciousness from AI. Doesn't feel like an alien to you? Reasoning. Yeah, and here we are. And it took 166 seconds, so almost 3 minutes of thinking. And we ended up with a few lines of code. And actually, I think they look different than what I got yesterday, but let's test it out. Let's have, let's forget about the cone-shaped egg. Yeah, I started to think about the chicken that can lay such one. So. And a moment of truth. I will press F5, and you see. What the heck is that? It's a mistake again. However, yesterday we ended up with this code. Yeah, you can compare this longer one and watch this. This is a perfect egg. It is actually, I think, better than the one that I've designed in the previous episode that I have here, based on some more simplification that you can find on Wikipedia. And this one is even more organic, the one generated by Claude. But I would tell it that the version that this version gives just a ring. Actually, you know what? I will make a screenshot and tell him. Yeah, that's what I got. That's what I got. What's wrong with you, man? That's what I got. And the image shows what appears to be a thin ring or disc shape. I see the issue. You just got a ring instead of a solid egg shape. Let's fix it with a more reliable approach. So let's, and this time it was 5 seconds because probably because of the whole context. And let's see if this time it is better. F5. Ta-da! You see, but this one is a bit strange. It is complex, but it is symmetric in a strange way, you see? Yeah, so I was lucky yesterday to get this beauty, right? And we can now walk through and compare. So we have this beauty, we have Grok with this super sexy thing. We have another try from Grok with this bike stuff. We have, I don't remember which one, with a coin. Then we have a half of an egg. Then we have something that didn't work. Then we have a ball, not an egg really, but getting closer. Then we have this strange thing that I maybe a head of a monk. I don't know. Then we have this. This is my. I think it's close to the first Grok version. Also very eggish. Then we have 3 minutes of thinking to end up with this, and then when we said no, we have that. And let's make another screenshot here, and let's see if we can explain that this is not right. This is wrong. Eggs are thinner at one end and are usually a revolution solid. To be very precise and engineering. I see the issue now, the image. Okay, now only 3 seconds, so it's not thinking that much. A proper revolution solid. Let's see. Revolution solid. Yet another version from Thinking Claude 3.7. Where the heck is that? Okay, so we have an empty screen again. Didn't work. So, wrapping it up. If you want to create a good looking toy, an ornament, an item for a game, then AI definitely today can do nice stuff. Look at the pumpkin that we have created here. If you want a precise thing that is engineering, a piece of engineering, a piece of gear, and it needs to be correct and match something in real life, you still need to learn OpenSCAD or FreeCAD or Fusion 360, but that's not that tough. And I encourage you to watch some of my FreeCAD tutorials. It's not that tough, but I think one day AI will be able to do that. Thanks for watching and see you next time. Bye bye.